now it's time to look at the graphs of polynomials. Remember, when we talk about polynomials, it's important to write them in order or standard form with their exponents in a descending order. So for example, if I had a cubic, it would start with my x cubed, and then go to x squared, and then the x, and then the constant term, right? And then you name it based on its highest exponent and on the number of terms it has. So if it's one term, we have a monomial, and then a two term is a binomial, a three term is a trinomial, and then a four or more is a polynomial, right? So in this case, this one would be a third degree polynomial. All right, so just keep that in mind whenever we are graphing these different polynomials. So different properties that we're going to look at with polynomial graphs. Okay, we're going to look at the end behavior, which we've looked at in the past, right? So it all depends on where the graph goes, to the left and to the right, whether it goes up or down. And it's always going to be set up the same way. It's going to either be as x approaches positive infinity, or as x approaches negative infinity. We want to know where y is going, and so either be positive or negative infinity. Or we'll write it kind of like interval notation, where instead of having the x and the arrow, we would just have an infinity, and then whatever y is doing, and a negative infinity, and whatever the y is doing. All right, they mean the same thing, it's just two different ways of writing them. Now, odd degree polynomial. So for that first one, because it's a third degree, it's an odd degree. So odd degree polynomials, the ends are going to be opposite. So it's going to have one positive and one negative infinity for the y's. For even degree, so like a quadratic, x squared, the ends are going to be in the same direction. So it's both positive infinity or both negative infinity. Keep that in mind. It's a little cheat to help you figure out stuff when you're looking at these polynomials. Okay, then we talk about the roots. Remember, roots can be solution, x-intercept, root, or zero. All four of those mean the same thing. So the number of x-intercepts is always going to be the degree. So for that first one that we looked at, it was a third degree, so that means it has three real roots, or three x-intercepts. Okay, the number of terms, right? So for example, you might have a graph that does this number. Right, so here's a term, here's a term, here's a term, here's a term. Right, so the maximum number of terms is a degree minus 1. So in this case, because there's 4 terms, it would have to be at least a 5th degree polynomial, because it's the degree minus 1. And that's just the maximum number of terms. All right, an odd degree for domain and range, both domain and range are all real numbers. So like the cubic or even a linear is x to the first power, and a linear goes in every direction forever. So negative infinity, positive infinity, negative infinity, positive infinity. For an even degree polynomial, your domain is all real numbers. So for example, that quadratic, it's going to go left forever, it's going to go right forever, but it doesn't go up and down forever. So your odd, both of them are all real numbers all the time, and even, just the domain is all real, and your range is based on your max or min. All right, your intercepts. Okay, an odd degree always crosses the x-axis, and an even degree may not. Right, so odd degree, again, we talked about how it goes, your domain and your range are all real numbers. So that means it goes up forever, it goes down forever. So at some point, it's got to cross the x-axis. Even degree, like that quadratic, may not ever touch the x-axis, depending on where it is, because it doesn't go down and up forever. And then multiplicity of roots. So an equation that has a multiple factor, or with a multiple factor, has a multiple root. So for example, x minus 3 to the 4th power has an x-intercept at 3, but multiplicity of 4, because it's there 4 times. All right, so we'll keep that in mind when we're looking at our polynomials. All right, end behavior polynomials. So here we have an example of our odd degrees, right? They're going to go in opposite directions forever. Okay, so for this one, as x approaches negative infinity, so as our graph goes to the left, it's going down. So y approaches negative infinity. And then as it goes to the right, it goes up forever. So as x goes to positive infinity, y goes to positive. They're always going to be opposites. You have one of each, a negative and a positive infinity for odd degree functions. For even degree functions, that means that they're going to be doing the same thing. So in this case, they're both going up forever, so both of these are positive infinities. In this case, they're both going down. So these are both negative infinities. Odds are opposites, evens are the same. And then graphing polynomials, right? So we're going to look at the degree and end behavior. So if it's odd or even, look at your coefficient. It's going to tell you which direction it's going to go. You want to know where it crosses the x-axis, if it touches and turns, or if it's a multiple root. And then where it crosses the y-axis for your y-intercept. Find our max and min, and we're going to use a calculator for that. Make our lives a little easier. And then you can make a table of values or find certain points to graph when you actually graph the polynomial. So a couple of examples. So for this first one, all right, I just want to talk about those key features. So the first one we can do is end behavior. So this one I know is even because I'm going up both times. So I know that it's an even degree. And my end behavior, both are going up. So as x goes to negative infinity, y is going up. As x goes to positive infinity, y is still going up. Okay, I can look at my max and my mins. All right, and I've got 3. All right, I'm going to change colors here. So this one is going to be a relative min. This one is going to be a relative max. And this one's going to be an absolute and relative min, because it is the lowest, right? But this one's not the highest because the graph continues to go up past. So those are my max and my mins. All right, we can also look at the type of degree. I know it's an even degree, but because I have 3 terms, that means it's got to at least be x cubed, which actually makes it have to be at least x to the 4th because it's the degree minus 1. And then I also have 3 x-intercepts, which means it's got to be at least x cubed. So that means that this polynomial is at least x to the 4th or bigger in an even degree. All right, my domain for this function is all real numbers. The domain for every polynomial that we look at is all real numbers. Right, the range, because it's even, is based on the max or the min. So in this case, it looks like my minimum is at 2, maybe negative 50. All right, so that means I go from negative 50 up to positive infinity. So that would be my range. All right, looks like my y-intercept might be at negative, I don't know, we're going by 4s, I guess, or maybe 2, so maybe negative 12 for my y-intercept. All right, and then I've got an x-intercept at negative 4, at negative 1, and at 3. So those are some of the key features for this polynomial. All right, for this example, I want to graph or describe as much as I know about this particular polynomial. So just looking at my equation, I know that I have an odd degree, and it's a 3rd degree. All right, so that degree tells me that I'm going to have a maximum of 3 x-intercepts. All right, and I'm going to have a maximum of 2 terms. And because it's odd, my end behaviors are going to be different. And a normal odd function goes from bottom left, and then all this stuff can happen in the middle, and the top right. But this negative is going to reflect it. So that means I'm going to be top left and blah, blah, blah to bottom right. So my end behavior is going to be as x goes to negative infinity. So as I go to the left, my graph is going to go up to positive infinity. And as x goes to the right, my graph is going to go down to negative infinity. All right. And then I can do talk about my actual max and mins and stuff like that by just looking at my graph. We'll graph it on the calculator. So on the calculator, we got y equals, I'm going to type this in. So I've got a negative x, and I'm going to go caret 3. All right, and then plus 5 times x. Go to my graph. All right, and I need to see some of these important points. Some of the important points are your y-intercepts, your x-intercepts, and then your relative max and mins. All right, so to find my x-intercepts, I'm going to go to the second trace, 0. Remember, solution root, 0, x-intercept, all mean the same thing. And it's going to ask me 3 questions, left bound, right bound, and guess. So I'm going to get my cursor above for the left, below for the right, and then tell it to guess. So I've got 1, 0 at negative 2.24. So negative 2.24. All right, the other one I saw was at 0. That one's at the origin, so that was a little easier. Then I'm going to do the same thing over here. So second trace, number 2. And now I'm going to scroll over this side and left bound again above. So I want something on the left. Scroll to the other side for the right, tell it to guess. And we get positive 2.24. All right, and then the other points I'm going to use are going to be the max and the min. And we can have the calculator look at those too. So I'm going to go second trace, and we'll start with that minimum. So I'm going to go to minimum number 3, and it's going to ask me those same questions, left bound, right bound, guess. So I'm going to go on the left side of that minimum, press enter. Go on the right side of that minimum, press enter, tell it to guess. So I have a minimum at negative 1.3, negative 4.3. All right, that's a minimum. And then my relative max, I'm going to go second trace, I'm going to go number 4 for maximum, and scroll over to the left side, enter, scroll over to the right side, enter, press enter for it to guess, and I get 1.3 and positive 4.3. Alright, so now to graph all of this, I'm going to draw my x and y axis in here. Try to. Alright, so I've got a point at negative 2.24, which is right about there, 0, 0, and positive 2.24. I've got negative 1.3 and then negative 4.3, positive 1.3, positive 4.3, and now I'm just going to connect. I come down, back up, and back down. So there's my graph. And the only thing I'm missing is my domain and range, which because this is an odd function, both domain and range are all real numbers every time. And that's basically the gist of graphing polynomials. We're going to use our calculator to get the actual graph, but the equation can tell us all sorts of stuff about our key features just by the degree.